As you think about your API design, one key thing to consider is what data each individual API should return. It's very easy to create an API that returns too much or not enough data from the client's perspective. First, if you're only building one or a few clients that you control, and you're able to make updates to both your clients and your APIs in tandem as changes are made, then don't think too much about what data to return from your API endpoints. Let the client's needs dictate what you should return, and aim to return exactly what the client needs, no more and no less. Following this approach will maximize the fit between your API and all of its clients and minimize waste, both developer waste as you try and build the right thing, as well as waste during the use of your system in terms of how much data is being retrieved or sent over the wire. It will also make your task of designing the API a whole lot simpler. You want to avoid returning too much data. If the client only needs one record or one part of a large record, then returning a huge collection of large, fully hydrated objects is wasting a lot of computer and network resources. Of course, you don't want to return too little data either. This often results in the client having to make many more calls than would be optimal in order to get all of the data it needs. How many API calls should a given screen of your client of your API need to make? Think about that for a second. Ideally, clients shouldn't have to make any APIs to get the data for a given screen. Making 0 calls will increase the speed and reliability of the screen in question dramatically. One obvious way to achieve this is not to require any data, but another is to leverage caching and local data storage options so that in many cases the data a screen might require is already on the page or on the client device at least. For screens that need data, and the necessary data isn't already local, the ideal number of API calls to make in order to populate that entire screen is 1. If you only have one client that you're building a back end to support, you can optimize your API to fit its needs. If you have a bunch of APIs and a bunch of clients, you can still get the benefits of designing your APIs to suit each client by following the backends for front ends or BFF design pattern. When following this pattern, you should structure your API based on what your client needs and when it needs it. It's likely that any given screen the client needs to display will have certain data requirements, and these may need to come from a variety of resources in your backend system. Consider creating a single endpoint the client can call that will provide all of these resources in a single response, rather than forcing the client to make numerous calls. Don't expose endpoints the client doesn't need. Keeping your web API surface area small makes it easier for client developers to work with your API and improve security. Whenever possible, perform the necessary data aggregation on the server and then provide the exact data the client needs in as few API calls as possible. For a general purpose or public API that will have numerous unknown clients, you typically want to define both summary and detailed representations of each resource. You can return a summary representation when you're returning a list, and then you can use detailed representations with individual resource responses. Another consideration for collections is how you will support filtering and paging. Filtering usually doesn't impact the model, but paged responses may, and you should define a standard format for this. For resources that have relationships or sub-collections, choose what to do with them in your summary and detailed representations. For a detailed representation, typically you'll include at least one level deep of your sub-collections. But here too, you might consider whether you need paging if those collections are large. Another approach that can minimize the size of the representation's collections is to provide them as URIs along with paging support. Here's an example of GitHub's public API with a partial list of what you get when you view a user representation. Notice that instead of including all of the user's followers, there is instead a followers URL property which points to an API endpoint that would allow you to get all of the followers. Expanding the followers URL, you get that list of followers, once more with summary records, not details. By default, 30 records are returned at a time, but you can provide query string parameters to page through the data. Note that GitHub's API does not include pagination information in its data representations. Instead of putting paging information in the representation itself inside the response DTO, GitHub uses headers to provide navigation links. By contrast, the Harvest Time Tracking Services API returns page information as well as links as part of the response document itself. As you can see, there are different options to consider for how you want to expose paging and other metadata as part of your model, or as part of headers or some other way that you wish to communicate that to the client. As you can see, you'll need to make some decisions about paging, which may affect your model types. The first question is whether you'll support paging at all. If not, you can probably skip the rest of the questions. But if your API's result sets are large, it could result in performance problems. I recommend you support paging from the start. The next question is if you want paging data to be a part of your response model and returned in the body of your responses. Alternately, you can return paging metadata and links in response headers. My recommendation is to use response headers like GitHub does. This is supported by web standards described in RFC 5988 as well. You'll need to decide on some default values for starting page number and page size. Most APIs I've encountered default to page 1 for the first page rather than using a zero-based index, and a default page size between 30 and 100. If you don't have a preference, I suggest starting with 1 and 50. I also recommend you be consistent across your entire API. Don't choose different page sizes as your default for every different collection resource you expose. It will just make it harder for clients of your API to have a consistent experience. Finally, you'll need to come up with the standard names for your variables. I recommend page and per page, as these are clear and fairly common. Another common choice is to use offset and limit. If you do choose this naming convention, your offset should start at 0, not 1, for the first page of results. Let's consider some characteristics of good API models. We'll start by looking at 4 characteristics of good models. First, they should be well named. This can be difficult. Naming is hard, but it's one of the most important things you need to consider as part of your API design. It will impact both models and your URIs. Second, your API models should be well factored. That is, each representation should be separated from others such that they are cohesive and as loosely coupled as possible. The resulting models should be well sized. Strive to include the right amount of information in each model. Obviously, this will vary depending on your domain, your clients, and a host of other factors, so it does require some thought. Finally, try to get your models to be stable. Changes to your API models should be rare, and, if absolutely required, should ideally only involve adding data, not changing or removing it. One way that you can get more stable, more well-sized and well-factored models is to use intention-specific models for different operations, such as doing a new instance of a model versus a modification to a model. When we talk about well-named models, they should use resource names that clients understand, not internal names if there's a difference. They shouldn't reveal internal architecture, such as database concerns. They should avoid unnecessary suffixes, like DTO. It's okay in your C# code if you want to refer to a certain model as a DTO, but don't let that be exposed to the client of your API. Models that do not map directly to resource representations may use suffixes that can help to make their intent more clear, such as request, command, response, or result. Finally, consider how your names are going to be used. Names are frequently used both on the server and in documentation tools like Swagger. For instance, to create an author, you might have a C# type called createAuthor command that's on the API, but the client might not see that. They might just post the endpoint as a bunch of JSON, and they never actually care what the name of the type might be in your C#. They just supply JSON that corresponds to its properties. The same is true for the response or the result in most cases. Well-factored models avoid mixing too many concepts in a single representation or resource. Instead, large concepts are separated into distinct resources. When a resource includes several closely related primitive-typed fields, it often makes sense to leverage objects for these. For instance, a line segment might need 4 values to represent its start and end points. These could be 4 separate primitive fields at the root level, or there could be 2 point objects, each with an X and a Y field. When breaking resources up, avoid one-to-one relationships where possible. There is usually a more suitable way to split up large resources. One exception to this is summary versus detail representations, but remember, those are actually representing the same resource. They don't really have a one-to-one relationship. Many different but related tiny models will require a very chatty interaction between client and server, so you want to avoid having models that are too small. But large models with many subrecords, which may in turn have many subrecords and relationships, can be very resource intensive. You want to aim for a Goldilocks size that is just right for most clients. And if you only have one client, then obviously make it suit that client. One common approach to this is to use summary records in lists and detailed records for individual representations. This is so common that you can think of it as a best practice. Provide clients with size-limiting tools like paging and filtering, as this can also help to right-size the amount of data that you're returning. Your most used resources and their associated models should be the most stable elements in your API, since they are going to be the things that are depended on by the most number of clients and the most parts within a client. Where possible, make changes in an additive fashion to avoid breaking your clients. And if you have more than a single client, consider versioning upfront as part of your API design. When you do make breaking changes to your models, be prepared to support clients as they migrate to the new version.